Talk now about another data type, the list. Lists are denoted with square brackets. So they start with an opening square bracket and end with a closing square bracket. And they are an ordered collection of 0 or more elements. What I mean by ordered is that the order of elements will never change if you look through a list. So the first element in a list is always going to be the same, which is not necessarily true of other data types in Python. I say 0 or more elements because an empty list, or just opening square bracket to start the list, closing square bracket to end the list, is a valid list in Python. Now, unlike a set, the elements in a list don't have to be unique. So, the example 111 is a valid list. The elements in a list can be any type, even other lists. So, if I have multiple lists, it would look like this example here where I open the first list, then I open the second list, close the second list, and then close the first list at the end here. So really this is like nested lists where the outer list is this blue color and then the inner lists are these yellow and pink segments respectively. Lists are mutable, that means they can change, and you can change the order of elements or add and remove elements from a list. To create a list, you can use square brackets, or you can use the list function with a single argument, which turns that single argument into a list, or something called list comprehension, which we'll cover later. Now, lists are very flexible, but they can be slow. And they can be slow because the computer can't know how long the list needs to be until you do operations like add elements to the list or append to the list. And so the computer or Python interpreter is having to create space in memory when you add things to a list or find a new place to store this list. And so it's not as fast as, for example, in a language like C or Fortran where you would pre-initialize some space for this list based on the length you'd expect it to be. The dynamic nature of the list is what causes it to be slow. So we have some examples here where we're creating a list. We're calling it A1, again with the assignment operator, and this contains a bunch of strings. We can also create a list with a single argument, so in this case just the list with a single element z, the string. And so if we print this, we can see it looks identical on the first case because we're using the square brackets to create the list. And then here we've created a list with one element. As I mentioned in the previous lecture, we can use len on a list to get the number of elements in the list. So len of A1 is 6, and that makes perfect sense. We have 1, 2, 3, 4, 5, 6 elements in this list. And as with strings, we can use operators like plus and times. Plus will add two lists together into a single list, and times, by extension, will repeat the elements in a list. It's like adding the list to itself multiple times. And so in this example, A1 plus A2 is all of the contents from A1 plus the content from A2 in a new list. And again, this is ordered, so the content in A2 in this case comes after the content in A1. And then if we do A2 times 3, that's like doing A2 plus A2 plus A2, which is going to give us the list Z plus the list Z plus the list Z, which is a list of 3 Z's. Now some operators don't work, so if we try and do A1 divided by 2, this will give us an error. It's a type error for unsupported operand types for division, list, and integer. This means we can't divide a list by an integer. Now, as with strings, lists have some important methods that we can use to change them. So we can use .remove to remove an element from a list. We can sort a list with .sort. We can reverse a list with .reverse. We can add elements to the end of a list with .append. And then there's this interesting operation here called .pop, which will remove an element and then give that element back to you. This is called returning that value. So L.pop actually is a value, and the value is the element that was removed from the list. And we can also pass in what's called an index. And so L.pop0 would give us the 0th element in this list, which is the first element, except Python numbering starts at 0, so really the 0th element. And it would remove that from the list. So if we go ahead and run this, if we remove A from the list, of course, we no longer have that first element, A. We can then sort the list, and because Python is aware of alphabetical order, this is going to sort by alphabetical order. So we have B, D, E, W, X. That's all of the elements less A sorted in alphabetical order. We then reverse this, so it's now backward. We add the letter P onto the end, the string P with .append, and then we're using these pop methods. So L.pop will take the element off the end of the list, which in this case is this P string. It will remove it from the list, and then it'll give it back to us. It'll return that value. And similarly, we can do the same thing at the beginning of the list by specifying 0 as the index. Now, there are some important performance implications, which I briefly mentioned before. So to add an element to the end of a list, you could either take that list and add another list, so this would be a list of one element, or you could use L.append, and these both end up with the same thing. They end up with a list of the original contents of L with that new element X, but the second one is actually much faster because of the way Python is handling the memory for this behind the scenes. So just something to be aware of. Lists are not the most performant of Python data structures, but they are very flexible. Now, a list is an example of a sequence, and so is a string. So it's logical to follow this lecture, or to follow the string lecture with the lecture on lists, because they're both examples of sequences. And so you can access one or more elements of a sequence by using square brackets. And of course, we used square brackets to define a list, but square brackets have double duty. They're contextual. So they mean create a list in some context like this, and they mean get me the elements of a sequence at given indices in other contexts. So that's a little confusing at first, but trust me, it'll make sense with time. So the indices, again, they start at 0, and then they go up to the length of the sequence minus 1. So if you have 6 elements in a list, those elements will be numbered 0, 1, 2, 3, 4, and 5. Because we start counting at 0, the last element is at the index of the length minus 1. You can also use negative indices to count backward from the end. So -1 is the last element, -2 is the second from the last, and so on. And you can give a starting point, an ending point +1, and a step size to get the elements of a sequence. And these will have default values if you don't specify them. So start will default to 0, n + 1 will default to the end of the list, and step size will default to 1. So this is really best taught by example. So we have this list here called letters. And let's actually just print out this text here. So we can see this is the list we have. We're using square brackets on letters. So this will tell us that we want to get an element of this sequence. And in this case, we're getting the 0th element, which is A. And sure enough, the output of this is A. We can also use negative indices to look starting from the end. So -1 will be the last element. So that will be M. And sure enough, we're printing M. And we can use this notation here with the start and the end +1 to get a subsequence. So we can get a list from this list that contains only the elements from indices 0 to 2 in this case, because again, this is end +1. And so that would be element 0, 1, and 2, or A, B, C. Now we can also add in this third parameter here, which is the step size. And so since this is 2, this will skip 1 every time we get a value. So we'll start at index 3, which is 0, 1, 2, 3. So we're starting here. We're going to index 12, which I'm not going to count this, but it's one of the later ones here. And then we're going by a step size of 2. So we're going to go 3, 5, 7, 9, 11. And so we're going to get D through L skipping 1 every time. And then you can also use the default for one or more fields by just omitting a value. So if I have nothing and then a colon, that means that the nothing is interpreted as starting at the start of the sequence. The nothing here is interpreted as ending at the end of the sequence. And then I specify a step size, so this is interpreted as starting at the beginning, ending at the end, and going with step size of 3. So we're going to do A, skip B and C, get D, skip E and F, get G, skip H and I, get J, skip K and L, and get M in this case. So this is a very powerful way of getting sub-sequences. And again, this works on strings as well. So if I create a variable named myString, and then print myString, and print, let's just choose some numbers here, like 1 to 5, say. Then we get the substring in this case from indices 1 to 4. So 1, 2, 3, 4. So this is a very powerful way to work with sequences.